Hello everyone, Mr. Fawcett here, and we are about to finish this lesson. We're on part 4 of our Understanding the Derivative 2.8 lesson. We are headed to the 5th and final page here. I think I can squeeze all these questions in. Yes. So let's jump right in. We are given a graph of a derivative called p prime. So I'm just going to label, I guess it's already labeled, but it doesn't hurt to make it big and noticeable. 21 says, on what intervals is the graph of p of x decreasing? So again, we don't need to make a number line here because we're not given the algebraic form of the function. We can pretty easily just look at our, well, you know what? Let's make a number line. I think that might be easier for some of you to read rather than just look at the graph. So if you feel like doing this for future problems, go ahead. If you understand how to do this without making the number line and just by looking at the graph, perfectly fine as well. So this number line is going to represent p prime of x. So we have zeros for p prime at -3, 0, and +3. And this is nice because we don't have to test any points. We can just look at the graph. Between -infinity and -3, our derivative is positive. Between -3 and 0, our derivative is negative. Between 0 and 3, our derivative is negative. And between 3 and infinity, our derivative is positive. So if we're looking for where p of x, which is the original function, is decreasing, well, we want our derivative to be negative. So p of x is decreasing on the open interval -3 to 0, union 0 to 3. You do have to break this up. We can't just say -3 to 3 because the derivative is 0 at 0, which means it's neither increasing nor decreasing, so we can't include 0 in our decreasing interval. We also do need to give a justification. So again, because p prime of x is less than 0 over or on these intervals. (22) it just asks the other side of this question. On what intervals is the graph of p of x increasing? So we're just looking for where p prime is positive. So p of x is increasing on the interval -infinity to 3, union 3 to positive infinity, and include our justification because p prime of x is greater than 0 over these intervals. And again, if you haven't already paused the video and attempted all of these questions, I would encourage you to do that now. As we move on to question 23, it says, at what values of x does the graph of p of x reach a relative maximum? I am not going to draw this diagram again because I think we've hammered that point home. But for the original function to have a maximum, that means, or a relative maximum, that means the derivative must go from positive to negative. You know what? I am going to draw it out because I think it is just that important. We're still in the beginning stages of learning this, so it's not going to hurt. And for those of you who may have not watched our previous video, this will help you out. So if we have a relative maximum, right, that means the derivative, or the slope of the tangent line, is going to be positive right before that relative maximum, and it's going to be negative right after that relative maximum. And this holds true whether we have a parabola for our relative max or whether we have a hard corner as our relative max. Over here, the derivative is not 0. We don't have a horizontal tangent, but that doesn't mean we don't have a relative max, because a relative max just means the slopes of the tangent lines go from positive to negative. And over here, the maroon tangent lines, their slopes are positive, then negative. But both of these are examples of relative maximums. So relative max here and relative max over here. So is there a spot where the derivative goes from positive to negative? Yes, there is, at x equals -3, because p prime of x goes from positive to negative. 24 just asks us at what values of x does the graph of p of x reach a relative minimum. So this is the same idea. If you just flip these graphs over, the derivatives would go from negative to positive, because the slopes of the tangent lines would go from negative to positive. So this occurs at x equals 3, and our reasoning is just, it's the same, we just flip the signs, because p prime of x goes from negative to positive. And I'd say technically we should even say at this x value. I don't think you're going to lose credit for it on the AP exam. I'm just a little OCD about this. So we will say negative to positive at this x value. But again, the important thing is just stating that it goes from negative to positive, as well as mentioning x equals 3 and x equals -3. Okay, our last question for this page and for the video. Yes, we will erase this work because we will not need it for this question. It says, approximate the value of p of 1.8 using the tangent line approximation if p of 2 equals -3. So our tangent line is going to go through the point 2, -3, and then we're going to use that tangent line to approximate p of 1.8. So as always, if we start with a equation of a tangent line, we're going to start with point slope form. We are given our x1 and our y1. So we have y minus -3, so y plus 3. We'll leave our slope out for now because we don't know that yet. And then in parentheses we have x minus 2. Now, this is a tangent line, so we're trying to find the slope of the tangent line, which is the value of the derivative at that specific x value. So we need to find p prime of 2. And we can just look at the graph and look at it right here. So p prime of 2 gives us -4. So our tangent line looks like this. And then we just have to use it to approximate p of 1.8. So substitute 1.8 in for x, simplify for y, or solve for y, and we're done. So I'm going to get y plus 3 is equal to positive 0.8, and then I get y is equal to, subtract 3 from both sides, negative 2.2. All right, that's going to wrap it up for part 4 of this video and the lesson altogether. Hopefully see you next time. We will be talking about something new, but until then, as always, enjoy the rest of your day.